All right, part 3 of vectors. What we're going to find now is the projection of V onto W. And there's 3 ways of doing it. First 2 are just formulas. So the projection of V onto W is just V magnitude times the cosine of alpha, which is the angle between the two. Or the projection of V onto W is also equal to V dot W over W magnitude. So what are you actually finding? You're finding how much V contributes to W. So if I have a vector, let's say this pen or this marker is your vector, and I've got another vector right here, how much is this vector contributing toward that one? Well, since they're orthogonal, it's literally not helping one bit. It's like saying what lands on the ground first. If you drop a bullet or you shoot a bullet straight horizontally, well, the gravity doesn't affect, or the horizontal velocity of the bullet doesn't have any impact on the gravity because they're perpendicular to each other. If this vector was like this, it is producing a little bit of a tailwind, if you will. So this, how much of this is going to contribute to that? It actually is us, and it's that much is going to contribute. Not the whole thing. The whole thing, now the whole thing is going to contribute in that direction because they're literally going the same direction. And if it's like this, well, it's only this much is going to contribute in that direction. And this is how 2 ways of finding the projection. Then I'll give you a 3rd way, which makes more sense to me, and it involves the geometry involved. All right, so let's say I've got a drone. Its flying velocity is at 20, 30, and a south wind is, well, south is just going straight north. So that's 0, 10. So we can find the projection. Well, 20, 30, 20, 30, it's kind of like this. And then a south wind is going straight north. So it is going to project some. It's going to contribute in that direction. Now, if it was blowing this way, it would actually have a negative effect. If it was blowing this way, it would have a negative effect, or this. It has no, but since it's going kind of the same direction, it should have a value contributing. So we can figure it out. How much is V contributing to U by doing V dot U? So 0 times 20 plus 10 times 30. So that's 300. And U magnitude, 20 squared plus 30 squared, 400 plus 900 squared, or 1300. All right, so 300 over the square root of 1300, 36.06, 300 divided by square root of, and I get 8.32. So if this is in miles per hour, it would be miles per hour. That's much direction. It would be helping 10 because that's what the magnitude of V is. So it's helping significantly, 8.32. Geometrically, we could figure that out by setting up a graph. 20, 30, say it looks like that. And then we've got the 10. So like that. So here are my 2 vectors, this and this, and how much is it contributing is going to be, imagine a flashlight right up here shining straight perpendicular to this. This is how much it's going to contribute right there. We need to find that distance, and that's the projection of V onto U. That's your projection of V onto U. So we can use trig to figure that out. We know that U is 20, 30, and we know that V is 0, 10. So we can find the angle between them. We'll call that alpha by using our equation. Cosine of alpha equals U dot V over U magnitude V magnitude. So cosine of alpha equals 300 over square root of 1300, and then the magnitude of V is still 10. So then we can find the inverse cosine of all that. We get 33.7. Okay, so we have this angle, 33.7. I'm going to zoom in. And this is 33.7 degrees. Okay, and this is what we're looking for right there. That's our answer. That's the projection of V onto U. Well, we know this is 10. So then we can just say, well, the cosine of 33.7 equals x over 10, adjacent over hypotenuse. So 10 times the cosine of 33.7, 10 cosine 33.7 equals 8.32. This doesn't really need a formula to remember. You can just draw that. Well, you need to know this formula to find the angle between them. Once you have that, you can find this, which is 8.32. All right, so that's the projection of V onto U. What if I had a vector that was 6, 8, and I had another vector which is 3, 4. So 6, 8 is this, 3, 4 is this. You can see that they're the same direction. So how much does, if this is U and this is V, how much does V help with U? Well, looks like it's helping its entire magnitude because they're going the same direction. So let's project V onto U. So the projection of V onto U is going to equal U dot V over U magnitude. All right, U dot V is 18 plus 32, 50. And U magnitude, 6 squared plus 8 squared is 100, so we get square root of that is 10, so we do get 5. So how much of V contributes to U? Well, 5. Does that make sense? Well, if I did 3 squared plus 4 squared, the magnitude of V is actually 5. So yes, the entire V is going to project onto U because they are parallel with each other and going the same direction. If U was backwards, going the opposite way, U dot V would be negative 50 divided by 10, which is negative 5. So negative 5 would work against U. All right. So that's projection of two vectors. Almost done. All right. The work, another equation, is equal to magnitude of force times the distance. So basically force times distance. So if you've got a 20-pound dog and doesn't want to walk, so you end up having to drag it for 50 feet, how much work? While you're applying 20 pounds, drag it, distance is 50, so it would be 10 with a couple more zeros, 1,000, and the units would be foot pounds. So 1,000 foot-pounds, you multiply the force times the distance. All right, so last type of a problem. Let's say I've got, this is like the traditional one like this. We've got a car on a hill. So here's my car on a hill, and let's say it weighs 4,000 pounds. And it's I'll say 20-degree slope. Okay, so how much force is required to keep that car from rolling down the hill? Well, Newton says that for every force there's an equal and opposite force if it's staying still. So there is a force, there has to be a force going up the hill, and we can figure that out. So what we do is we take this and we project it onto that. So I'm going to make my vector a little shorter here so it works. So this is 4,000. We can go like this and make a 90-degree angle. And this is our X right here. That's how much force is applying to the truck to keep it from going down the hill. Alright, so we know what weighs 4,000 pounds. That's this length. And we want to know how much that is. Well, this is a right triangle, so if this is 20, that's 70. Alright, and this is 4,000, so we can find, if I call that X, you can see this triangle that forms. This is X, this is 70, this is 4,000. So now you can do the cosine of 70. Or you could say this is 20, so you could do the sine of 20, doesn't matter. So cosine of 70 equals x over 4,000, multiplied by 4,000. So 1,368 pounds of force just to keep it from rolling down the hill. That's what that vector is right there, the green vector. All right, I think that's enough on vectors.